Good afternoon, Algebra 2. This is Mr. Morales. I'm going to be going over your test review over rational expressions. So let's begin with number 1. Now, our instructions overall ask us to factor and perform the required operation and then simplify if possible. So number 1, we have a quadratic equation and we are asked to factor it. So to factor it, what you do is find the two sets of factors. Oops, I didn't mean to move that. The two sets of factors that when I multiply them using FOIL will revert back to this original equation. So to get the first term, the x squared, I would need an x times an x. To get the next term in my solution, I need to find the two numbers that multiply to a negative 35, but will add up to a negative 2. And those two factors are negative 7 and positive 5. There's no more to do there, so my answer is just x minus 7 and x plus 5. Now we're going to continue our factoring process, but now for number 2, we have a leading coefficient that is greater than 1. When this scenario arises, you take your leading coefficient and you multiply it times the constant at the end. So now I have the equation x squared plus 7x. 6 times a negative 3 is a negative 18. Now I am left to factor this quadratic. So to get the x squared, I know it's going to be x times x. Then I need two factors that multiply to negative 18 but add up to positive 7. And those two factors are positive 9 and negative 2. However, whenever you have a leading coefficient higher than 1, you have to bring it back in and divide both of your numeric answers by that leading coefficient, in this case 6. First of all, if possible, you want to simplify it to a whole number. If not, then just simplify it into a smaller fraction. So 9/6 would simplify to 3/2. 2/6 would simplify to 1/3. However, we don't leave these factors in fraction form. What you do is you take the bottom of the fraction and you bring it up next to the x. So I would have for my first factor 2x with that positive 3 from the numerator. And then for my second factor, I would bring the second 3 up to the x. And I would get 3x minus 1. Here are my two factors. That equals 6x squared plus 7x minus 3. Moving on to number 3 now. So now I have some simplification and division, essentially. My top equation, I'm going to go ahead and break it down into its factors. X times x gives me the x squared. Two factors that multiply to give me a negative 6, but add up to a negative 1 would be negative 3 and positive 2. On the bottom, I'm going to go ahead and I'm going to factor out a 3 from here and here. So I'm taking out a 3, and then 3x divided by 3 leaves me with an x. Negative 9 divided by 3 leaves me with a negative 3. Now I see I have common factors that can be eliminated. I have x minus 3 on the top and the bottom. So in my numerator, I have an x plus 2 remaining. In my denominator, I just have that 3. So my answer would be x plus 2 over 3. Your choice if you want to leave it in parentheses or not. Number 4, same type of problem. This one involves factoring like we did before. So let me go ahead and factor 2x squared minus 3x minus 9 first. I'll do that right here on the side. I'm doing it separately because it has a leading coefficient greater than 1. So I'm going to take my 2 times my negative 9, and I get x squared minus 3x minus 18. Now I need my factors for this quadratic. X times x gives me x squared. What two numbers give me a negative 18 when I multiply and add up to a negative 3? That'd be negative 6 and positive 3. Now I have to go back and divide both numeric answers by my original leading coefficient. The first factor, negative 6 over 2, gives me the minus 3, so that's a nice whole number. But then I have to do the 2 and bring it to the front. I have to do that whole bottoms up kind of thing. We bring the bottom of the fraction up to the top, or next to the x. So those are my two factors in my numerator. X minus 3 and 2x plus 3. On the bottom now, I have a perfect square. What two numbers multiply to give me x squared? That would be x times x. Notice I have no regular x's, or in other words, I have 0x. So what two numbers would multiply to give me a negative 9 add up to a positive, or add up to a 0, and that would be a minus 3 and a positive 3. Now wherever I have common terms, I can go ahead and eliminate. And that would be the x minus 3s on the top and the bottom. So my final resulting answer is 2x plus 3 on the top over x plus 3 on the bottom. They look similar, but because the top one has 2x and the bottom one only has 1x, and the 3's aren't compatible with 2, it stays just as is. You have x plus 3 as your denominator, and 2x plus 3 as your numerator. All right, continuing on. Number 5. So for number 5, I had a bunch of work that I did originally, and then I realized I wasn't following one basic rule, so I made a huge problem way more complicated than it needed to be. So let me explain the right way to do this. First of all, this is multiplication, so the one thing I don't need to multiply two fractions is a common denominator, which is the trick I fell into because I wasn't paying attention. So let's begin with our first fraction, x plus 2 on the top. Let's factor the bottom, excuse me, which is going to be x times x gives us x squared. And then x plus 2 times negative 1 gives us negative 2 and adds up to positive 1. So those are our bottom factors. Times, let's factor the numerator, which would be x plus 2 times x minus 2. It's the perfect square like we talked about, I believe, in number 3 or one of the other ones above. And then on the bottom, I'm going to go ahead and factor out a 2 from the 2x plus 4. 2x divided by 2 is x. Positive 4 divided by 2 is just 2. So now to multiply everything, I have a common denominator of x plus 2 times x minus 1 times 2 times x plus 2. So basically all the stuff at the bottom is just being multiplied in one big row. Same thing with all the stuff on the top. On the top I have x plus 2 times x plus 2 again times x minus 2. So let's remove anything that's common. I have that common here. And then I have, let's see, another x plus 2 common here and here. So my remaining answer, let me scroll up a bit to make some room. And my remaining answer is going to be on the top. I have an x, oops, hand's not working. There we go. I have an x minus 2 remaining in my numerator over, I have this 2, I like to put it in front, times x minus 1. There we go. After much unnecessary work, I realized that's a very basic, easy problem. Now, number 6 requires a little more work. So, because we have essentially what we have is a division problem. One fraction divided by another fraction. So what I'm going to do is I'm going to first start off with our top fraction. I'm going to go ahead and bring it to the side over here and factor everything out. So on the top, the factors of x squared plus 8x plus 15 are going to be x plus 5 and x plus 3. The bottom factors, because it's a perfect square, is going to be x plus 5 and x minus 5. Now that's my numerator. My denominator, I'm going to go ahead and do that separately. Now I might as well just change the color of it too. So for my second fraction on the top, to get the x squared minus 2x minus 15, I'm going to factor that. I need x times x is x squared. Two numbers that multiply to negative 15 but add up to negative 2, and that would be negative 5 and positive 3. The bottom piece, this right here, notice I have an exponent greater than 1. So refer to number 2 above. You have to factor that out. Multiply the 2 times the negative 15, find those factors, and then divide them by 2. If you do all of that correctly, you should end up, for the bottom piece at least, with x minus 5 and with 2x plus 3. Now, also remember, there's a fun little song that everyone loves that goes with this, that I won't sing, but I will just recall it for you. And that is when we're dividing fractions, we don't ask why. So I have my first fraction here. I'm not done with the song yet, I'm aware. X plus 5 over x minus 5. That's our first fraction, the numerator. When you're dividing fractions, you don't ask why. You flip the second fraction and multiply. So everything that was in the denominator in this reddish box is now going to be my numerator. And then everything that was in my numerator in that reddish box above is now going to be my denominator. Now essentially everything is basically, I can really think of it like this, one big long fraction. And now I can start crossing out all the stuff that is common. So let's see what I have. I have x plus 5, so that can go away. I have an x plus 3 on the top, and x plus 3 on the bottom, x minus 5 on the top, x minus 5 on the bottom. So what remains? Well, in my numerator, I have a 2x plus 3, and in my denominator, I have an x minus 5. So there's your answer for number 6. For number 7, we have subtraction, which means I will have to have a common denominator. So let's go ahead and work number 7 out. So first thing you want to do is take our first fraction, and well, actually what I want to do is, I notice that I already have, oops, I keep doing that. I notice I already have a common denominator. My common denominator is 2x plus 5, which can't be factored or simplified in any other way. So they're really both ready to go. All I gotta do is the math in the numerators. 3x's minus 2x's leaves me with 1x. Positive 3 minus a negative 5 becomes 3 plus 5, which is just 8. There's absolutely no more simplification or factoring I can do, so that is my final answer. I have x plus 8 in my numerator over 2x plus 5 in my denominator. Pretty simple for that one. Moving on, let's go on to number 8 over here now. Number 8, it's addition, and I do need a common denominator. So let's break apart our first fraction. On the top, x minus 1, we can't do anything to it. In my denominator, 3 and 9 have a 3 in common, so I can divide out a 3. 3x divided by 3 is just going to be x. Positive 9 divided by 3 is positive 3. Plus, my numerator for my second fraction is just a 2. My denominator is an x plus 3. So what does the left-hand side, which is bigger than the right-hand side denominator, have that the right-hand side doesn't? The right-hand side needs to be multiplied by 3 to make it same denominator as the left side. So now I finally have one common denominator, which is with the 3 times x plus 3. That's on both fractions now. And I need to do the math on top. So on top, I have x, then I have a minus 1 plus 2 times 3. Well, 2 times 3 is 6. Negative 1 plus 6 gives me a positive 5. And I cannot go any further from there. I would prefer you to leave it in this form. Some students are going back and multiplying the 3 times x and the 3 times 3, and they would get this answer, 6 plus 5 equals 3x plus 9. And I guess for this test in particular, I would probably only take off half because the instructions do say to factor, simplify when possible, and I think this is better, this 3 and the separate, but they do technically are the same thing. So I would use the first version, not the second one, to get full credit. You're not mathematically wrong if you do either one. Number 9. So number 9 now says 5x over x plus 2 plus x plus 3 over x plus 1. So let's go ahead and let's rewrite these. So for my first fraction, oops, see if we'll get to lock down. I have a 5x on the top and an x plus 2 on the bottom. Both pieces cannot be manipulated in any other way right now. On the top, I have an x plus 3 in the numerator, and then x plus 1 on the bottom. So what makes the left different from the right? The left has an x plus 2, but it does not have an x plus 1. So I'll multiply 1 down on the bottom, and whatever I do to the bottom, I have to do to the top. Now the right-hand side has an x plus 1, but it needs an x plus 2 to make it common. Whatever you do to the bottom, you do to the top. So there's my resulting work I'm going to have to do now. So essentially, what I have here now is a common denominator of x plus 2 times x plus 1. Let's go ahead now and multiply everything out on top using FOIL. 5x times x is 5x squared. 5x times positive 1 is a positive 5x. Positive x times x is a positive x squared. Positive x times positive 2 is a positive 2x. Positive 3 times x is a positive 3x. And positive 3 times positive 2 is positive 6. So we keep our same common denominator, which is x plus 2 times x plus 1. And then let's go ahead and combine like terms. 5x squares plus another x squared is 6x squares. 5x's positive plus 2 more is 7, plus 3 more is 8x's. Excuse me, I think I made a mistake there. 5, 6, 7, 8, 9, 10. Yeah, that makes more sense. Because apparently Mr. Morales can't add that well late in the afternoon. So that's 10x. I apologize for that. Then I have plus 6 at the end. All right, so now what I'm going to do is I'm going to take this same fraction, and now I have my common denominator of x plus 2 and x plus 1. Now 6, 10, and 6 can all be divided out with a 2. So I'm going to factor out a 2 from the numerator and divide everything else by 2. So 6x squared cut in half gives me 3x squares. 10x cut in half is a positive 5x. And then positive 6 cut in half is a positive 3. All right, so now here's the question though. I need to figure out the factors for 3x squared plus 5x plus 3. So I'm going to pull up a side sheet of paper because this one, I should put a star around it, has something very interesting that happens. So 3x squared plus 5x plus 3. 3x squared, let's see my pen going. 3x squared plus 5x plus 3. If we use our rules we learned above, we multiply the leading coefficient times the constant at the end. So we get x squared plus 5x plus 9. However, name all the factors that give you a 9. There's only really like 3 sets. Negative 9 times negative 1, positive 9 times positive 1, and negative 3 times negative 3. Those are all the factors. Oh, and positive 3, excuse me, times positive 3. Out of all these factors, is there any pair that if you add them, that would give us a 5? And the answer is no. So when that happens, our answer stops right here, and we can't go any further. And that's because this top piece right here, you can not factor, or not factorable. And that's because if you were to graph it, you would notice that it doesn't ever hit the x-axis. It doesn't make contact, so there's no solutions. So it's unsolvable after that point, and that's where you would stay for number 9. So that's your final answer right there. Now, number 10. This one takes a little bit longer, but we got to do it. So here we go. Our first fraction has a numerator of x plus 3. Let's get the factors for the bottom piece. X times x is x squared. How do we get a positive 9 with multiplication and a positive 6 through addition? That's going to be with a positive 3 times positive 3. It's a little longer. Minus my next one. I have x on top. So let's throw that there. Let's put everything in parentheses. And then let's factor the bottom. It's a perfect square, so it's going to give me x plus 3, x minus 3. You've seen the perfect square binomial many times. You should be recognizing it now at some point. Now, what makes the left and right denominators different? The left denominator needs an x minus 3 in its life. So we'll put one there, and we'll put one there. The right-hand denominator needs an extra x plus 3 in its life over here. So we'll put that here and here. So now we've finally decided that we have a common denominator of x plus 3 again, and then x minus 3. That's the same for both of them now. Now let's do the math on top. On the top, what I'm going to go ahead and do now is I'm going to go ahead and start FOILing everything. X times x is x squared. X times negative 3 is negative 3x. Positive 3 times x is positive 3x. And then you go on to the right side. Negative x times x is a negative x squared. And then I have negative x times positive 3, which would give me a negative 3x. And that's all the pieces on top. Now let's go ahead and combine like terms. Just need to go ahead and squeeze this in over here. So I have my x plus 3 times x plus 3 times x minus 3. And then let's see, x squared minus an x squared leaves me with no more x squares. Minus 3x plus 3x leaves me with none of those. And I'm stuck with this singular, it looks like 3x. And I see that I forgot a number somewhere. Oh, I forgot to do this part up here. Positive 3 times negative 3. I should have a negative 9 attached over here at the end. My bad. Sorry, guys. If you caught that before, that is a huge my bad. Good for you if you're doing it right. If you didn't catch it before, shame on you. You should have caught that. Not let you make that mistake. So now let's keep going. So I have a negative 3x minus 9 on top. All right. So here's my answer as of now. In the numerator, I have negative 3x minus 9 on top. And I have all three pieces on the bottom. Usually, you want to see if you can keep simplifying things anymore. And the top does let us do that. Negative 3 and negative 9 can both be divided by a negative 3. So negative 3x divided by negative 3 leaves me with a positive x. Negative 9 divided by negative 3 leaves me with a positive 3. So I divided everything by negative 3. Then I have all my stuff on the bottom. X plus 3, x plus 3, x minus 3. Anything cancel out? You bet, right here. So now my final resulting answer is a negative 3 on top with an x plus 3 on the bottom and an x minus 3 next to it. You can't go any further from that. If we had 3 x's or something like that, we could divide, but that's as far as this goes. So other than my brief faux pas with missing my minus 9 here and the issues with number 5 that you may or may not have noticed, these are your solutions. And of course, if you have any questions about how I got these or need further explanation, please feel free to ask me either during class or come in the morning. All right, guys, so those are your solutions. Best of luck, and hope to see you before the test. Get some extra advice if you need it. All right?